Hello everybody, this is Doug Young, and in this video I'm going to just talk briefly about cis and trans alkenes, when do we need to use those terms, and how do we identify what sorts of alkenes are cis and what are trans. So again, right, we've been talking about a few different functional groups, and this term cis and trans, it only applies to alkenes. So we're talking about the C-C double bonds. You don't use cis and trans with hydroxyls or aldehydes or ketones, just alkenes. And again, right, alkenes are just those carbon-carbon double bonds we've been talking about. So not a CO double bond O, that's carbonyl. Just a C double bond C, right, where we just have something attached to these carbons. And I would look at this alkene, and I can call one cis and one trans. Specifically, this would be a trans alkene right here, and this would be a cis alkene. And in fact, when I have those alkenes, I need to say if they're cis or trans. I can't just say, oh, this fatty acid, I've got a carboxyl over here on the right-hand side. This thing has an alkene in it. I need to say, in this case, if they're cis or trans. So how do we identify when we need to say it? And how do we decide, how did I know that the top one is trans and the bottom one is cis? Now, if I look at a bunch of different alkenes here, I want to point something out. One is that if you take a look at these alkenes, only two of these need to be named cis or trans. So here I have an alkene with only one group hanging off of it. Or let me circle all the alkenes first, actually. So I've got these four alkenes, right? And I have on these alkenes things that are not H's. I just have one thing that's not an H. Here I have two things coming off of the alkene that are not H's, just CH3 groups. Here I have two things coming off that are not H's. And here I have 1, 2, 3 things that are coming off that are not H's. The only time that I need to use cis and trans is when I have one thing coming off of each of the two carbons. So I have two things all together, right? Here I have one thing coming off of this carbon and one thing coming off of that carbon. Here I have one thing coming off of that carbon and one thing off of that carbon. So you only use, right, so I'll put a star here, you use cis and trans only when there is one group, and by group I mean something that's not hydrogen, one group coming off of each alkene carbon. Right, so when you have one group coming off of each of the carbons in the alkene, like I do up here in these ones, that's when you need to name it. So I don't need to use cis and trans over here, because yes, this carbon has one group coming off of it, the methyl group, but this carbon over here on the right just has H's. There's no groups here. Right, so I don't need to say cis or trans. And if I look over here on the far right-hand side, right, yes, this carbon right here has one group, but this carbon has two groups, so I don't use cis or trans. Because what cis and trans are supposed to help me figure out is when I have a molecule, right, here I have 4 carbons in a row with an alkene in the middle. So if I have 4 carbons in a row with an alkene in the middle, I can draw it like that, or I can draw it like this. And those are two different molecules. They have different properties, they have different physical properties like melting points and boiling points. Turns out they have different biological properties. Our proteins and enzymes recognize cis and trans differently. So I need to say what is what. And if you go down here to the definitions of cis and trans, a cis alkene is when those groups that I was talking about are on the same side. So when the two groups are on the same side of the alkene. Right, so when those two groups are on the same side of the alkene, you can think about it sort of in terms of sound, right? Like cis, same side. Those all have the S sound. It's all when you have the same side. Plus the cis has like a C in it, and if you look at how these alkenes are going to look, they're always going to look kind of like they have like a C shape, right? Where they have sort of like the two groups are on the same side of one another. And then trans is when they're on opposite sides, right? So two groups are on the opposite side of the alkene. Are on, whoops, are on the opposite side of the alkene. So let's take a look at these two examples up here, right, that I have. I said that these two in the middle, I need to use cis and trans with them because each of those carbons has one group on it. So if I look at my alkene here, I'd say here's my alkene, right, and I'm just going to draw that as my plane. Here's where my alkene is. I'm just drawing a line right through where the CC double bonds are. And if you notice the one on the left, I have a group here and a group here. Those are not on the same side. They're on opposite sides of that line, which means this would be the trans alkene. And if I look over here on the molecule on the right-hand side in the middle, the two groups that are coming off of my alkene, they're on the same side of this dotted line, right? So that would be a cis alkene. So when they're on the same side of each other, when you draw a line through the CC double bond, if they're on the same side, that's cis. If they're on opposite side, there's trans. So let me show you some more examples. So here's a few more, right? We're going to look for which alkenes actually have, which ones do I need to do cis and trans on? Here's those two fatty acid things I was telling you about before, right? So if I look at this, I'd look at this and be like, oh, look, here's my alkene. I'm going to draw a line through my alkene. And I see that there's one group coming off of the alkene carbon is going right there, and the other group is right here. And those two groups are not on the same side, they're on opposite sides. So therefore, this must be a trans alkene. This would be a trans alkene. If I look at this one, again, here's my CC double bond. Again, here's that line, but I have a group here and a group here. Therefore, those two groups are on the same side of that line. Therefore, this must be a cis alkene. If I look down, let's go one to the right. Here I have an alkene. I have an alkene right here. I can draw a line right through like that. On this carbon, the group that's coming off of it is right here. On this carbon, the group that's coming off of it is right here. So if I look at my line separating the two, it looks like they're on opposite sides. Therefore, this would be a trans alkene, right? They're on opposite sides of that double bond, right? Here's my CC double bond. I'm getting kind of messy here. Here's the line where my double bond was. Here's one group. Here's the other group. They're on opposite sides of that alkene. If I go clockwise here, I'm going to go ahead and move on to the right-hand side. Again, here is my CC double bond. But in this case, if I look at this carbon over here on the left has one group on it. Great. But this carbon on the right has two groups on it. So that means I don't have to worry about cis and trans, right? So there's going to be no trans, no cis designation for this. I can't call that one cis or trans because I don't have two groups to compare. I actually have three groups, and that's a whole other naming system. We're not going to talk about E and Z, but that's just, you don't use cis and trans for tri-substituted alkenes that have three groups on them. Now, if I look at the last one over here on the left, I need to make some more decisions here. I've got three alkenes. Here I have one alkene right here. Looks like I have a group here and a group here, so only two groups, which is perfect. Here's my alkene. And if you look at these are on the opposite side, so this must be a trans alkene. But I've got more alkenes than that, right? So one molecule could have more than one alkene. Let's take a look at this alkene here. Looks like I've got a carbon and a carbon. And this also has two groups, right? I have one group coming off of this and one group coming off of here. These two groups are on the same side as one another, so that must be cis. That's a cis alkene there. And then if I take a look at this last alkene over on the end, here's a carbon, but it actually doesn't have a group on it. It's just H's. And then the other carbon, yes, that has a group on it, but I don't need to name cis and trans for that alkene there on the end because these are both H's, and so there's no difference whether or not it's on the same side or opposite side. So no cis and trans for that one because I remember that I need to have each one of the carbons in the alkene needs to have one non-H group on it. So I don't need to worry about that. No cis and trans for that one either. No cis and trans for that either. So that's kind of a brief introduction on how to identify cis and trans for your alkenes. It's a relatively limited naming system. because you have to have an alkene, and the alkenes can only have one non-H group on them, and that's how you decide if they're cis or trans. So if you have any questions or comments, please leave them down below. Happy studying.